Hello! So on this video, I will be going over electronics for your Voron build. This video will not cover the bed, hot end, or controller. Those will be separate videos, but this will cover all the other electronics that you will need for building your Voron. So the first thing we are going to look at is your power supply. With the Voron V2, the recommended power supply is a Meanwell LRS, either 12 or 24. The voltage of the power supply determines the components that you will be using for your Voron build. Everything in the manual and the bill of materials is designed around a 12-volt power supply. The reason for that is, as the standard ramps is only rated for 12 volts, that is what everything is designed around. While the advantage of the 24-volt power supply is the hot end heating up quicker and quieter, more efficient motors, it does require modification to the ramps kit. If you do not feel safe modifying your ramps, you simply stick with the 12-volt power supply. In effect, the printer will function mostly the same. You may notice a little bit more noise and a slightly longer heat up time for your hot end, but functionally your prints will be exactly the same. Now, for the size of the power supply, one thing you may notice is compared to some other 3D printers, this is only 200 watts. The reason for that is with the Voron, the bed is mains powered. So even though you may be running a 500, 600, 700 watt bed that is powered directly from the mains off your wall outlet, either 110 or 220 volt. So the power supply is really only powering the hot end, your motors, your controller, and any other incidental electronics you have plugged in, such as LED lights. So the LRS 200 is perfectly sized for the Voron. The mounts are designed to work with it, and it is a name brand high quality power supply. We don't recommend using a AliExpress power supply or that one you ripped out of an old Inlet A8, for example. These ones can be purchased at Mauser, DigiKey, Arrow, and a few other reliable vendors. Do not buy them off AliExpress. Odds are they will be a clone at that point and not a Meanwell. If you are tempted to get the larger 350 watt one, be aware it does come with a fan that will kick on and is actually quite loud. So we do recommend just simply sticking with the 200. It's passively cooled and it is large enough for your printer build. Nobody so far has come across the need for more power in a build that used an LRS 200. Now another component you will need is something to power your Raspberry Pi. In front of you, I have two options. These two are buck converters. This is simply your standard wall wart. What you can use is a buck converter to convert your input voltage, either 12 or 24 volt, down to the 5 volts required by the Raspberry Pi. This one does the exact same thing, but it has two USB ports to output instead of a direct line. In this one you have to assemble some pins on here for the in and out. This one is simply plug and play. Another option is taking a wall wart and either leaving this plugged in the wall and running a USB cable to your printer, or taking it apart and essentially wiring it directly to the mains inside the printer underneath the hood and using that to power your Raspberry Pi. Another option some people have gone with actually is purchasing a small power supply specifically for the Raspberry Pi and other incidentals. There are some that you can get that output multiple voltages, or simply a 5 volt compact one if you wish to go that way. And for getting power into your printer, this is the inlet that the bill of materials calls out for. You can source these on Amazon or AliExpress. They're relatively inexpensive. They do come with a built-in 10 amp fuse when you get yours. I'd recommend popping this off and making sure the 10 amp fuse is installed. You do need it. Make sure when you do purchase this that you get the rectangular one. If you purchase the one that has this flange around it with these screw mounting holes, it will not fit in the designed mount for the power inlet. For heating your bed, you will require a solid state relay, an SSR. This converts the low voltage direct current from your controller into a high voltage alternating current that will power the heater for your bed. The specified one is a Omron 10 amp rated SSR. This one in front of you is a 40 amp rated generic one off AliExpress. My Omron one is actually in my build right now, so I do not have one on hand to show off. For your SSR, these fail in a way so that if this does break, what it will do is it will constantly heat your bed. I will go into that more detailed when I do the video on the bed itself, but essentially you want to use a quality solid state relay. The Omron one, while a little expensive, is worth it for the added safety. I'm going to say this just because people will cheap out and get the Chinese ones. If you cheap out and get a clone or a non-quality solid state relay, get one that is rated high. The reason for that is most Chinese SSRs are rated for a amperage they actually are not safe with. For example, a 40 amp rated Chinese SSR will not likely survive at 40 amp. However, at 20 amp, it probably will function fine all day, every day, for as long as you need it. Since your bed is only 5 amps on average, you probably would be okay getting a 40 amp relay. You have a very large safety margin. However, I'm just saying that because I know people will buy the cheaper ones. We do recommend getting a quality one. Either Omron and Cridum is another quality SSR. In front of you are the components for the FSR, the force sensitive resistor. This is what you need for your nozzle probe. This and a printed housing and a 5mm pin. This is the light sensor board that a lot of people ask what it's for. And the reason you need the light sensing board is on it there is this little diode right here. This, along with this potentiometer, is used to measure light levels. We do not need this. So what you do is you cut off or you desolder the light sensing probe and you solder on your force sensitive resistor. The potentiometer allows you to adjust at what pressure this essentially will trip, and this allows you to tune the force needed for your FSR end stop to activate. If you do solder directly to these pins, you have to take great care not to accidentally melt this plastic that surrounds it. If you do, you can damage the FSR and it will not trigger properly. That is something to keep in mind. And these are the two end stops for the Voron V2. This is the one that is SPECT in the bill of materials. It is a KW10 micro switch. These go for about $1 for 10 pack on AliExpress. They're extremely cheap, they're very reliable, and they're dead simple. Essentially, when you wire this up, we recommend that you wire it to the 2 outer wires. Ignore the middle pin. This wires in a naturally closed state. What that means is, say you have a break in your wire somewhere along the run, either a wire gets pinched or a crimp comes loose, for example, it will automatically assume that this limit has triggered and prevent you from crashing your printer during a homing move. The other option is the Hall Effect end stop board. This is not a commercially available item, unfortunately. The designs and the bill of material are on the GitHub, so you would have to make this board yourself, or somebody on the Discord may have a few that were made a while ago or still be making them. You'll have to ask around. How this works is it mounts under the XY joint, and with a magnet installed in the X carriage and the location of the Y end stop, as it gets close, it will trigger the Hall effect sensor. There are 2 potentiometers here. This adjusts the sense distance. When you go to install this, one thing you have to keep in mind is the polarity of the magnet. So what I would recommend is, after you install this board and wire it up and turn your printer on, before you install the magnets, simply move the magnet close to it, and whatever polarity or side triggers it from the furthest away distance, that is the way you want it installed. If you install it the other way, essentially it may not trigger until it crashes. So you want to have the most trigger distance available. This is the Z probe. This is used for trimming out your gantry to the bed. It is not used for your nozzle or Z offset. That is the FSR. There are several different manufacturers of this probe. They're pretty common on AliExpress and Amazon. AliExpress they run for a couple of bucks. Amazon is around $10, I believe. This is labeled as a Photech, although I do believe it is a clone. With these, there is the PL08N and the PL05N. The PL08N has a longer sense distance. However, it is not as accurate. The PL05N has a shorter sense distance. We recommend the PL08N because with aluminum, you're not actually triggering it at 8 millimeters. It's going to be shorter. So depending on how thick your bed is and how thick the PEI is, it may not trigger until your nozzle is actually striking the bed. So that's why the PL08N is SPECT. If you do wish to try the PL05N and have better results, that may be an option, but that is something you'll have to look into yourself. We recommend this to be safe. Now, this isn't a component that is on the bill of materials, but this is a very common add-on that people add to their Voron. This is a filament runout sensor. This one is the Triangle Labs one. I'm saving this one for the build I will be doing very soon, but several of the users on the Discord are using them to great effect, and they are very reliable. There's also do-it-yourself options as well as options from other vendors. This would be a worthy add-on if you decide to go that route. However, it's not required for a printer to function. Thank you for watching this video. Again, if you have any questions, please feel free to ask them either on the Discord or below. I will make every attempt to answer you. And if there's anything in more detail you wish for me to go over, let me know. I will either reply in the comment or do a separate video on that in itself. Thank you, and have a great day.